Hi, this is Group 12 from the Computer Security Course School of Computing, Faculty of Engineering, University Technology, Malaysia. We will present you with a voice detection algorithm that is a machine learning algorithm that detects voice signal. First, let us introduce ourselves to you. My name is Tasneem.
I am Amirul Hajim. And I am Raja Muhammad Hafiz.
So, we are presenting a voice detector algorithm which is used to transfer the voice after detecting into text in a quick note system. So first, these are the scenarios. Amirul and Raja are in class when suddenly,
Hey Amirul, I have a lot of trouble following Dr. Madni lectures. How can you keep track of all the lecture notes without missing information? Isn't Dr. Madni a little bit too fast for you? Well, the secret is, I used to take notes, but sometimes, I do use my alternative ways to take notes without missing any part from the lectures. Oh, please tell me the secrets of it. Well, I used an algorithm that detects my voice. Then, after the detection, the voice is transferred into words, so whatever I say will then be written in the notes. What? Isn't it impossible to do that? It is possible when you use the speech-to-text technology by picking up on these vibrations and translating them into a digital language through an analog-to-digital converter. Oh really? How is that even related to taking notes? If you make research about it, you will find that the sounds are then segmented into hundredths or thousandths of seconds and are then matched to phonemes. A phoneme is a unit of sound that distinguishes one word from another in any given language. Still, I'm not answering the question there. I'm halfway there, so be patient with me. So, the phonemes are then run through a network via a mathematical model that compares them to well-known sentences, words, and phrases. The text is then presented as text or a computer-based demand based on the audio's most likely version. Oh, now I get it. I think I'm going to use the same technique as yours, Amirul. Thank you so much for sharing the secrets. Sure, no problems. Anything for you, my brother.
sometime after the discussion during class.
Tasneem, I have heard that you used speech-to-text algorithm for taking notes. Care to elaborate on the algorithm?
First of all, it used analog to digital converter. Human sound in normal environment is considered as analog data, but computer cannot work with analog data, so it needs to be converted into digital data. Next, microphone is used to translate the human sound into digital data in the shape of spectrogram graph. Last but not least, with this, the computer can now process the sound that has been translated into digital data to text.
Raja, care to elaborate on that?
First, the system executes the speech-to-text algorithm by measuring and filtering the waves in the spectrogram graph. Next, the sound is segmented and matched to the phoneme, which is a unit of sound to distinguish the word from one another. The phoneme then is compared to the well-known sentences, words and phrases from the network library. And lastly, the matching phoneme is then presented as a text.
Alright, good. Anyone want to add on regarding these text-to-speech? Amirul?
Oh yes? In security point of view, the system will set to work only with the user voice. Each person has its own voice frequency. So, the system is now secure to work only with the voice of the system's owner. I think this is the important aspect in using the text-to-speech algorithm.
That's all from Group 12. Thank you for listening to our animation explanation.